I'm going to present to you the work I have done as part of a final project of the course Big Data Analytics from the Harvard Extension School. The topic I selected relates to the life science and deals with distributed processing of unstructured data. Let me first give you a succinct presentation of a use case. Let's say that a chemical company submits lots of documents to another company. Those documents are in an unstructured format. They are in the form of PDF, portable document format. This document contains lots of valuable information. In particular, it contains the description of scenario used to demonstrate that the use of a certain chemical are safe for people, are safe for the environment. So one of the targets of this project will be to extract this information. This information, in fact, is also exposed in the table of content. So what we will be doing is we will extract this different type of scenario that are contained in the table of content. We will see shortly an example of such a PDF. Now the information that are in this document is confidential. So what I will do in the context of this project, I will only be using non-confidential document, so documents that are publicly available, some sample. So here's an example of PDF. This is just the extract of a table of content. As you can see here, it contains two types of scenario. This is the main scenario, and these are the contributing scenario, and this is the information that we will be extracting. Now this information, of course, will be stored in a different manner, either in the we'll see in the file system or in the database. But the idea behind it is to later on further combine that with other source of information, either structured or unstructured. As I said, the goal of this project is to efficiently extract the core information that is contained in this document, in this unstructured PDF, and to store them in a structured manner in a data store so that we can later on run any type of analysis against this data. Of course, for me, an indirect goal is also to better understand the Hadoop framework and what it can bring to process such unstructured data. The dataset used here would be made of around 2,200 PDFs, identical PDF, because I used the publicly available sample, which I replicated 2,200 times. Each PDF has a size of 700 kilobytes, so we'll have roughly 1.4 gigabyte of data. Here, of course, I limited myself to only 2,200 documents, but in reality, the company can deal with tens of thousands of PDF documents. Let's look at the overall architecture used for this project. It is based around the Hadoop framework, the distributed file system, the map reduce technique, and also the use of an NoSQL database, Cassandra. So the first step that we'll do is to load all this PDF, all this document into the distributed file system. Then we will process this input using various techniques. We will see, in fact, two specific design that deals with processing this input by extending the Hadoop framework. It will be based around the file input format and the record reader class. So by extending these two classes. Another design that has been looked at is to use the Avro serialization. The idea was to try to see whether it made sense to pre-process a file before submitting them to the Hadoop framework. Now, while using the Hadoop framework and running the MapReduce job, the target was to basically extract the table of content from this document and parse them, so parse each line and tokenize them, for ultimately storing them into two data store, one the Hadoop file system as a text, and the other one in a NoSQL database, in this case Cassandra. Of course, here the advantage of using Cassandra will be that we could use SQL in order to run queries against this data. So here's the technology used for this project. I run everything on a Windows 8.1 with 16 GB of RAM. I installed a virtual machine based on the Cloudera Quick Start CDH5 set with 8 GB of RAM. The CDH 5.0 had already the Apache Hadoop cluster already installed with all the Hadoop ecosystem, HDFS, MapReduce, Yarn, UA, etc. Then I used the PDF box library for manipulating, working with PDF documents, a very useful library that is available in apache.org. I also installed Cassandra. I compiled it from the source file. I did that also for the driver. Then I used the Apache Avro when I did the experiment on the data serialization. Another interesting set of script is called CCM, which is a Cassandra cluster manager that allowed me to run 3 Cassandra nodes on a single host. Let me now cover the constraint and consideration I used when designing the overall solution. The first decision was first not to split the document, otherwise it would be highly inefficient to extract the table of content if the content of the document was spread across multiple map tasks. The second element was that I was dealing with a rather large number of small files, so 3 different approaches appeared. The first approach, or what I call first design, was to process each file individually. The second one was to basically think that we could combine the file, combine them and merge them into one single file up to a certain size, and then process them into a map. And then the first design was more started to think, why not pre-processing the file, so combining those files outside the Hadoop framework, and then submitting this large file to the Hadoop framework. So in the case of processing each file individually, because we could not split the file, I created 2 classes that extended the file input format and record reader in order to tell to the framework not to split that file. Then on the second design, the idea here is to combine the content of many files together until we reach configurable file size. Then this file made of a combination of multiple files is then submitted to a specific map task. This used 2 base class coming from the Hadoop framework, the combined file input format and the record reader. Then on the third design, the idea was why not pre-processing the file before submitting them to the Hadoop framework. In order to do that, basically I use the Avro serialization and in order to evaluate whether it was a viable approach and how long it would take to serialize this file. Okay, in order to process all those documents, I created a mapper and a reducer. The mapper gets in the input the key value pair, so it gets the file name of a PDF as a key, and for the value, the binary representation of a PDF, which is an array of bytes. And then the output consists of a file name as a key and the textual representation of a table of content for the value. The reducer gets the output of a mapper for the input, so the file name for the key and the table of content, text content for the value. And then this is where the tokenizing is happening. The output is the file name, and each line of a table of content are then parsed and tokenized and sent as the output. Here you can see ultimately how the output is made of. Alright, now let's look at the design, first design processing document individually and see what that means to do it that way. So again, each PDF cannot be split. So basically it also means that each PDF will be treated as a split, and in HDFS it will be basically attached to a single block as it is shown here. Then this block, this split is sent to a single map. Ultimately, what that means is that if we have a 2200 split, then the Hadoop framework will create 2200 map tasks. One would think that then if you do 200,000 map tasks in parallel, then it can be done quite fast. But the reality is that it is very costly to launch a map task, because it's each map is launched within its own GVM, so it's rather slow. And by running this in the Hadoop framework, it took about 3 hours 30 minutes to process those files, so clearly not a very good solution. Now we can see in fact the output of MapReduce job. You can clearly see that there was about 2200 input to process, and the number of split created was equal to the number of files. And of course the job succeeded, but it took about 3 hours and a half. So this design is definitely not in the right direction. So let's now look at the second design. So in this design, still the PDF are not split, but they are combined together with a configured split size. And once the split size is reached, is then sent to a map. There is a parameter that is provided by Hadoop where we can basically configure this split size. I tried various split size to see the effect of that, and for this experiment I tried with 64 megabyte. Now what happened is that of course we will have drastically less amount of mapper, and we'll see that the performance has really been improved quite much. So actually let's look at that. So once the job ran, we can see that we still have of course the 2200 document to process, but because we set the split size to 64 megabyte, we then went to actually for this particular experiment we set the split size to 32 megabyte, which amounted to 41 split. I tried also with 64 megabyte, which then ended up with 21 split, and I put 512 megabyte to see how many split and the performance of it. But of course the improvement is pretty drastic. We went from 3 hours processing to only 20 minutes. The third design is the idea to pre-process a file before submitting them. I use the Avro serialization. There's not much to say here except that it took about 30 minutes to process them. I didn't go further in the experiment, but it was interesting to see the approach. If you want more information on the custom input file and custom reader, you can have access to the document. You will see explanation of each classes. For example, small highlight. For example, if you don't want to split a file, then you just have to override the isSplittable method and return false. It's as simple as that. But more detail in the document. Finally, let's look at one of the library I used for supporting the map reduce processing is the manipulation of PDF, such as the extraction of content and the transformation from binary to textual representation. I created an API that encapsulated the PDF boxes. For example, create an API that allowed to extract the table of content section and expose this API to the MapReduce classes. Then I integrated Cassandra in the same fashion. I created a set of APIs, so Java package that I exposed to the reduce task. And of course, by pushing the information to Cassandra, it takes a little bit more time. Remember that it took about 20 minutes to process the file and store the output in HDFS. With a Cassandra, it takes about 15 to 20 minutes more. But the advantage is that then later on, I can run any ad hoc queries against the information that I have. So I had about half a million rows that were created for as part of the processing. Alright, that's about all. Thank you very much.